This is fairly straightforward. I don't know how much I need to tell you, right? State whether the stone's acceleration, so the stone is thrown up, right? Notice that we're using 10 meters per second for our acceleration of gravity, right? It's thrown up at 20 meters per second, so it's going to slow down for 2 seconds, and then of course it misses the edge of the cliff, so it speeds up for, well, the next 3 seconds. 1, 2, 3. Okay. When the stone is on its way up, tell me whether the acceleration is upward, downward, or zero. Okay, just straightforward. Just see if you can answer that, right? Is it upward, downward, or zero on the way up? Is it upward, downward, or zero when it's right at the very top? Is it upward, downward, or zero when it's on its way down, I guess, or the top, right? Okay, so let's see. Next to each of the 6 images, draw a vector to represent the instantaneous velocity. Pay attention to the direction and relative lengths of the vector. So, for example, if this is 10 meters per second, make it half as long as this. Okay, if something is 30 meters per second, make it 1.5 times as long as this. Okay, so your vectors are going to look like this will be 20 meters per second. This could be 10 meters per second. This could be negative 10 meters per second. This could be negative 20 meters per second. This could be negative 30 meters per second, right? So when you draw it, that's the sort of thing you want to do. And then it says, at each image of the stone, draw in vectors to represent the force acting on the stone. So just pick some length, right? Decide which way that force vector is, right? This would be the force of gravity. So, I mean, I'm hoping this is obvious, but maybe it's not, right? And decide, does the force of gravity change significantly? Is it different here, 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 here? Just think about that. It's a mystery, right? Okay. And then it says, let's see, D, draw a velocity time graph to represent the motion of the stone. Well, I think you figured it out. Use this formula if you don't know what to do, plus AT. Acceleration is negative 10, okay? The initial velocity is 20. Just make a table, make a graph, okay? You should be good. Notice that we start off with a positive velocity. I bet we end with a negative velocity. In fact, look at that. Ooh, it goes down to negative 30. What is the gradient of the graph? That's the slope. What does that represent? Look at this thing, right? If this is y equals b plus mx, right? Think of what's in place. What's in the place of the slope? Okay. And then determine the height of the cliff. Oh, we can do this. I think you could just use this, right? S is ut plus 1/2 at squared. Don't you have that? It's 5 seconds, I believe, right? We have the time. We have the initial velocity. We've got the acceleration. Remember to use negative 10. Don't forget the minus sign, right? You ought to be able to figure it out, right? That it'll be the displacement from here to here. Should be a negative number. I guess make it positive. I don't know. All right. I think that's it.